Right, Fibre Channel FCOE is all about transmitting storage traffic, specifically SCSI-based storage traffic. So let's start out with some SCSI data. Now then, on a normal Fibre Channel SAN, this SCSI data is encapsulated within a Fibre Channel frame on the host bus adapter card in a server, and then it's transmitted over the Fibre Channel network. This encapsulation within a Fibre Channel frame still happens in a converged networking scenario, only there's an additional layer of encapsulation that occurs. The Fibre Channel frame is further encapsulated within an Ethernet frame or an FCOE frame. And importantly, this process of FCOE encapsulation leaves the Fibre Channel frame intact. Headers and all of the Fibre Channel related metadata such as source ID, destination ID, worldwide port names and the likes are all preserved, allowing FCOE networks to work together with existing Fibre Channel networks and Fibre Channel technologies such as zoning, Fibre Channel forwarding, fabric shortest path first, and things like that. This FCOE encapsulation process occurs at each and every hop in the FCOE network, meaning that every FCO switch that a frame traverses has to decapsulate and then re-encapsulate the FCOE frame. This is one of the major reasons that FCOE encapsulation is offloaded to an FCOE ASIC on a converged network adapter and not just done in software on the host CPU. By the way, converged network adapters, or CNAs, are PCIe network adapters that do both Ethernet and FCOE. And because Fibre Channel frames are slightly over 2 kilobytes in size, and normal Ethernet frames are only 1.5K, in order to avoid fragmentation of the Fibre Channel frame as part of the FCOE encapsulation process, the Ethernet network has to be configured to support at least baby jumbo frames, allowing for a one-to-one mapping between Fibre Channel frames and FCOE frames. Performance would suffer if each Fibre Channel frame had to be fragmented and delivered by multiple Ethernet or FCOE frames. So, as far as Fibre Channel is concerned, this converging of networks effectively replaces the two lowest layers of the Fibre Channel stack with Ethernet. That's the FC0 and FC1 layers that are responsible for things like physical cabling and link layer signaling. Now then, while we're talking about link layer signaling, let's talk about a link layer protocol called DCBX, Data Center Bridging Capability Exchange. DCBX is an extension to LLDP, Link Layer Discovery Protocol, and it's used to allow devices on a CEE network to automatically discover and configure each other's capabilities. For example, you can use DCBX to push certain network-related configurations to devices on the CEE network. And while we're down at the lower layers of the stack, it's worth pointing out, just in case it's not clear so far, FCOE has nothing to do with IP. Nothing. We're not encapsulating Fibre Channel within IP packets and then handing them over to IP for delivery. That's another technology altogether, a technology called FCIP, or Fibre Channel over IP, which is used to transmit Fibre Channel frames over IP networks, and it's only really ever used in replication configurations, where you've got a Fibre Channel SAN at either end of an IP network, maybe like an MPLS network, and you want to replicate data between those two distant Fibre Channel SANs. Anyway, FCIP and FCOE are totally different. Our current topic of FCOE has nothing whatsoever to do with IP. All sounds great so far, but let's remember back to earlier when we said that Fibre Channel is a high-speed, low-latency, lossless network, and Ethernet is, well, it's not. Ethernet is comparatively low speed and it's lossy. So how can the two be combined? Or how can Fibre Channel run effectively over Ethernet? Have the Fibre Channel guys been pulling the wool over our eyes all these years and only pretending that we need to pay lots of cash for low latency networks? Well, as it turns out, no, they haven't. In order to effectively converge these two networks, some major enhancements had to be made to Ethernet in order to allow it to transmit Fibre Channel storage traffic. But before we move on and look at the changes required in order to run Fibre Channel over Ethernet, let's quickly mention top-of-rack FCOE and copper twin-ax cabling. FCOE is commonly deployed at the edge of the network and works between the CNA and the edge switch, which is often located at the top of the same rack that the server is in a configuration we often refer to as TOR, or top of rack. These kind of intra-rack distances between the CNA at the bottom of the rack to the FCOE switch at the top of the rack make cable types known as copper twin-ax a great option. 10 gig Ethernet, and therefore FCOE, can be transmitted using copper twin-ax over distances commonly around 5 meters. So perfect for within a rack, and copper twin-ax cables require less power than other copper alternatives such as Cat6, 6A, 7 and 7A. In this configuration, copper twin-ax is much cheaper than running optical cables, and it's also often a better option than other copper cable choices due to the low power draw of copper twin-ax. So let's take a look at some of these changes. First up, these enhancements to Ethernet have already been made, or at least most of them have, and a new Ethernet has been born. And depending on who you speak to, it goes by one of two names: Converged Enhanced Ethernet, CEE, or Data Center Bridging, DCB. The standards body that was responsible for defining and documenting these changes to Ethernet was known as the Data Center Bridging Group, hence the name Data Center Bridging, or DCB network. The major changes that were implemented are the creation of a lossless Ethernet, or an Ethernet that's capable of providing a lossless lane on which storage traffic can run. Remember back to the animation on a previous slide where we isolated the FCOE storage traffic onto its own lane? Well, that lane is important, as traffic in that lane can be given priority over other lanes when congestion arises. This priority is indicated by tagging the Ethernet frame with an encoded priority. Another major change that is part of CEE or DCB networks is increased bandwidth, starting out with 10 gig but quickly moving to 40 gig and in the future 100 gig. And while converged networking is in some ways conceptually similar to server virtualization, it simply hasn't had the impact and the uptake that server virtualization has. And it arguably doesn't offer the same kinds of flexibilities that server virtualization does. Converged networking is almost entirely about infrastructure consolidation and the associated cost reductions that come with consolidation. So that's converged networking, all about transporting Fibre Channel storage traffic. Fibre Channel frames are encapsulated within Ethernet frames in a technology called Fibre Channel over Ethernet, or FCOE. But it needs a majorly improved Ethernet, which is now here and we call Converged Enhanced Ethernet, or Data Center Bridging. And at the end of the day, it's mainly about saving cost. Fewer network switches, fewer network cables, and fewer network interface cards, all resulting in less data center space, power, and cooling being required. So, on that topic of data center, let's move on and talk about data centers.